All right, so we've already done this bit where we represent the network into a matrix. So we have done a little bit of this with, you've seen it when we had communications, like they had a sort of a network diagram and we had to go then make it into a matrix. So it's very similar. So a matrix is a grid that stores information, and this is why we need it, because computers they need digital numbers to code, for it to do it. So we can use it to count the number of edges between points in the network. So if you look, if we think about that leading diagonal, which is that one, those numbers there, you would they would be a loop. Yes, because it goes back to itself. So you can see E has the loop, which is why it's got 1. Now, do any of the rest of them have a loop? No. So you'll see 0, 0, 0. So sometimes it's easy to fill that one in. And then you go across. Now, between B and A, how many pathways or edges are there? 1. So you put a 1. Now, between A and C, how many edges are there? 1. And between A and E, there's none. So then you go the next one, B and A, we said 1, B and C, 1. How many between B and D now? 2, awesome. And B and E, 0. Let's go, C and A is 1, C and B is 1, D and C is 0. And C and E is 1. Next one, D and I've got missing D and C, so that was 0. And I've got missing D and E, that's 1. And E can go to, I'm just going to go C and D and not A and B. All right, so that's that one. Okay, so just to recap, that's a loop. So a loop remember a loop is 1 edge, but a degree of 2. Okay? All right. So the next one, this next question, they want you've got the matrix and you have to make a diagram, a network diagram. So for this, I'm going to use letters A, B, C, D, E, and A, B, C, D, E. Okay? So I'm going to just type out my letters. Okay, so everyone's may look a little bit different, but if I look at A has 1 path between B, A has 2 paths between C, D has 1 path for D, and 1 to E. Okay, so next one, B to B is 1. So, wait a minute. So B to A is 1, B to B is 0. So, and B to C is 1. So, I'm going to put it across there. B to D, 1, and B to E is also 1. So, I might go around there like that. Okay, C, there's 2 to A, I've already done that. C to B, I've already done. C to D, I haven't. And C to E, I haven't. And there was 1. Okay, D, I've done the D to A, I've done the D to B, I've done the D to C. There's no loops, and there's 2 to E. So I'm going to see 2 here. No, in D. There's no loops in D. And then the last one, 1 to A, we've got. 1 to B, we've got. 1 to C, 2. Now, E to E, there's a loop. So we'll put a loop there. That was the loop. Okay? Okay, draw an adjacency matrix for this network. So an adjacency matrix will always be square. And it would have A, B, C. And A, B, C. A has a loop. Okay, so A to A, it had a loop. So it's 1. A to B, there is none. And there's A to C, there's 1. A to B, no. B does have a loop. And C, it has 1 to C. A and C have 1, C and B have 1, and it has a loop, which is 1 edge. Okay, so remember that it's representing the edges. So this is the number of edges. Okay.